All right, in Chapter 11, we only have a few kind of problems to do on Alex. So the first one, you're just doing some basic calculations. You won't really have to do anything with your graphing calculator. But once you get to the second two, we're going to have some hypothesis testing that you can use your graphing calculator for. Interesting enough, when you had the older graphing calculators, the TI-83s, they didn't have this test, but now these new ones that we have, they do have the test, and so it makes it a little easier to do the problem. So it says at a 5% significance level, test the claim that there is no preference in the selection of fruit soda flavors for the data. So if they're claiming there's no difference, that means your null hypothesis would be equal, and that your alternative hypothesis is that they're going to be not equal. And so you'll want to mark that down what your hypotheses are, because at the end we want to know should we reject the claim or not. But what we're going to do is we're going to put our observed values in list 1 and our expected values in list 2. So I'm going to go ahead and turn my calculator on. And so again, if I'm going to put those in my lists, I'm going to press the stat button. So I'm going to hit stat, and then I'm going to do 1 to edit. And if there's anything in there, I can clear that out ahead of time, or I can just type over the top, but I'm going to clear. And then I'm going to put my data in. So my observed 32, 28, 16, 14, and 10. And my expected value for all of them is going to be 20. 20, 20, 20, 20, 20. Enter. So now that I have all my data in, my observed in list 1, my expected in list 2, now I can perform my goodness of fit test, which is a chi-squared test. And so what I'm going to do is I'm going to press the stat button to get to stat. And then just like when I did my other hypothesis testing, I'm going to cursor over to tests. And then I'm going to scroll down to D. So I'm just going to go ahead and hit my arrow down and go down to D. And you'll see that D is the chi-squared GOF goodness of fit test. So D is the one I want. I'm going to enter on that. And it should be set that your observed is list 1 and your expected is list 2. If it's not, second 1 puts list 1, second 2 puts list 2. We do have to enter our degree of freedom. So our degree of freedom for this problem is n minus 1. We have 5 values. And so 5 minus 1 is 4. So I'm going to put 4 in there for my degree of freedom. Cursor down to calculate, and I am going to hit calculate. And so it gives me the chi-squared value. The chi-squared value is your test value. So your test value is 18. Also gives you your p-value. So if I go to, I'm going to go ahead and go to 4 decimal places, 0.0012, p is 0.0012. We put the degree of freedom, which is 4, and then that bottom row happens to be the list of the table that we're going to do when we have to do it on Alex. So I'll point that out again when we get to an Alex problem. Alrighty, so ask us what chi-squared was, ask us for our p-value, and then using the p-value we want to decide should we accept or reject the claim that there is not a preference for the soda flavors. So when we look at our p-value 0.0012 is less than our 5%, 0.05. 0.0012 is less than 0.05. Means we are going to accept the alternative hypothesis. The alternative hypothesis is that they are not equal. The claim is there is no preference, meaning they are equal. So we're accepting that they are not equal. So should we accept or reject the claim that there is no preference? We're going to reject the claim that there is no preference because we're saying they're not equal, instead of saying that they are equal, which is the no preference. So if we go ahead and look at the next problem here, I'm going to go ahead and scroll down on my computer here. And we'll look at another problem here. The next one here says the Census Bureau of the U.S. government found that 13% of adults did not finish high school, 30% graduated from high school only, 29% had some college education but did not obtain a bachelor's degree, and 28% were college graduates. To see if the proportions were consistent with those people who lived in Lincoln County area, a local researcher selected a random sample of 300 adults and found that 43 did not finish high school. 76 were high school graduates, 96 had some college education, and 85 were college graduates. At an alpha level or a significance level of 10%, 0.10, test the claim that the proportions are the same for all adults in Lincoln County as those stated by the Census Bureau. So again, the claim is that the proportions are the same, and so our null hypothesis will be the equal. The alternative hypothesis will be the not equal. Now on Alex, they have the observed values in the table, which in this case our observed value 43 did not finish high school, 76 were high school graduates, 96 had some college education, and 85 were college graduates. But on the expected value, they only have some of the expected values in there. So you actually have to do some calculations to do the expected value. So out of the 300 people, it says 13% did not finish high school. So 13% of 300 was 39. 30% graduated from high school, so 30% of 300 was 90. 29% had some college education but did not obtain their bachelor's degree, so 29% of 300 was 87. And then lastly, we had 28% were college graduates, so 28% of 300 is 84. And so you can see I filled in the expected values on the table. On Alex, not all of them will be in there. You'll have to fill those in. Again, we're going to grab our graphing calculator, and I'm going to go to my main menu here and go to Stat, and press number 1 to edit. And I'm going to go ahead and clear my lists. You can just type over them, but I like to clear them out just in case they're longer or shorter. And then I'm going to enter in my values. I have 43, 76, 96, and 85 for list 1. List 2, we had 39, 90, 87, and 84. And so once I have my data in my lists again, I am going to go to Stat, cursor over to the word tests. Whoops, I hit a different key. Stat, cursor over to tests, and go down to D. Now there's a quick way to jump down to D. It's using that alpha key. See, the alpha is in green, and so if I want to go down to D quickly, I'm going to look for the key that has a D above it, which in this case, I got to find it here, is the x to the minus 1. Notice there's a D. So if I want to jump down to D quickly, I hit alpha, I hit x to the negative 1 to jump down to D, and you can see that my calculator screen changed and went right to the chi-squared goodness of fit test. So you can either cursor down and enter, or alpha D will jump down to that test. Again, our observed list 1, expected list 2, our degree of freedom on this problem. We have 4 things, so we would do 4 minus 1, so our degree of freedom is going to be 3. And then I'm just going to go down to calculate and have it calculate. So our chi-squared value, or our test statistic, if I round that off to 3 decimal places, would be 3.531. 3.531. P-value 0.3168. 0.3168 if I go to 4 decimal places. And then again, you see that list down there at the bottom, which on Alex you will actually fill in that list. And I think they're going to have you round them off to 3 decimal places. I can't remember for sure, but we'll look at that when we look at the Alex problem. So What was the value of the test statistic? 3.531. What was the value of P? 0.3168. And then at a 10% significance level, can we test the claim that they are the same? So if I look at my p-value is 0.316, so forth. 0.3168 is greater than 0.10. Since my p-value is greater than my level of significance, then I have to accept the null. The null was that they are equal. And so in this case, it asks us, should we accept the claim? Yes, we should accept the claim because they are going to say that they are equal. Now, I'm going to scroll down to one more so you can see what the Alex ones look like. All right, here's one from Alex doing your chi-square goodness of fit test. More than one teacher has given the following advice. Choose answer C when blindly guessing among 4 answers in a multiple choice test, since C is more often the correct answer than either A, B, or D. Suppose that we take a random sample of 540 multiple choice test answers, the correct answers from the instructor's answer sheet, from introductory college courses, and obtain the information summarized in the first row of numbers in Table 1 below. The numbers are the observed frequency for each of the categories A, B, C, and D for our sample of 540 correct answers. The second row are the numbers in the table contain the frequencies of the expected for a sample of 540 correct answers if the correct answer is equally likely to be A, B, C, or D. The bottom row of numbers in Table 1 contains the value for our calculation, the observed frequency minus the expected frequency squared divided by the expected frequency. Each of the correct answers categories A, B, C, and D fill in the missing values of Table 1, then using the 0.01 level of significance, perform a test of the hypothesis that each of A, B, C, and D is equally likely to be the correct answer on the test in the introductory college courses. Round your responses for the expected frequency in Table 1 to at least 2 decimal places, it says. Round to at least 2 decimal places and put your responses in Table 1 to at least 3 decimal places. Round your responses in Table 2 as specified. So, what you are going to see for putting in your values is a table that looks like this. As you can see, not all of the expected frequencies are in there, and so you have to fill in those expected frequencies. In this case, they said that all of the frequencies were equally likely, and so since they're equally likely, you have a 25% chance of getting either A, B, C, or D. If you do 25% of your 540, I'm going to turn my calculator on here, 0.25 times 540, you get 135. So you're going to have 135 here, 135 here. They did the 135 here, and they did the 135 here. Now these values down here on the bottom, again, they have the formula that you could use, but when I told you on the calculator you had that list of numbers, they should match up here with this list of numbers. So I'm going to go ahead and go to my list and 1, and I'm going to put in my data. So I'm going to clear out what I have. In list 1, I am going to enter in 148, 149, 117, and 126. Those were the observed value from the test. My expected value, 25% of 540 for each of those, is going to be 135. So I'm going to enter in 135 for all 4 of those. And then I'm going to hit my Stat button, cursor over to tests, and again we're going to do D. So alpha and hit the x to the -1 or just cursor down to D. So my observed was list 1, my expected was list 2, my degree of freedom, since I have 4 options, is going to be n-1. So the type of test statistic is going to be your chi-squared. The degree of freedom here is going to be 3. And so I'm going to enter that in, and then I'm going to hit calculate. So when you cursor to the right, you'll be able to see your list, but you see the one that says CNTRB. The first value there is going to be your value for A, 1.252. 1.252. My second one, if I cursor over, and make sure you don't enter or anything, cursor over, is going to be 1.452. 1.452. If you cursor over, you're going to see the last two, 2.4 and 0.6, which are already in my table. So the CNTRB row is this row in your table where you're doing that calculation. And then, of course, you can see your chi-squared value, which should be 5.704, or whatever it says to round to, at least 2 decimal places. So 5.70 I could round it off to. My critical value for this one doesn't do the p-value, it does your critical value. And so to find your critical value, you have to use the ALEKS calculator. All right, so we got to use the ALEKS calculator in order to find the critical value. So on this one, when we're doing our critical value, we are doing the chi-squared test. So we're going to put that in there. We're just going to use alpha here. Alpha is 10%, and then our degree of freedom on this one is 3. And so when I enter there, I am going to do my critical value to at least 2 decimal places, it says. And so my critical value should be 6.25. 6.25. So then we are going to have to answer the question, can we reject the hypothesis that it is equally likely to get A, B, C, or D on our test? So when I look at that, I look at my test value is 5.70. My critical value is greater than my test value. 5.70 is less than 6.25. And all right, so if I grab my picture here of my drawing of my value, it's a chi-squared test, so it goes from 0 and up to chi-squared. My critical value was 6.25. So if my test value is less than 6.25, we are going to accept the null. If my test value is greater than 6.25, then we're going to reject the null. In this case, 5.70 would actually fall in the section that is less than, so it's over here in the section where we would accept the null. So we're accepting the null, saying they are equal. The question asks, can we reject the hypothesis that we're equal? Well, no, we're going to accept the hypothesis. We are going to say they're equal. So can we reject the hypothesis? No, we cannot reject the hypothesis. All right, the next kind of problem that we have in Chapter 11 is your chi-squared test for independence. And in order to do this test, what we have to do is set up a matrix. And so what you're going to do is press second function and matrix, which is on your x to the -1 key. So if I go to my calculator here, again, we're going to hit second function. So second function is in blue, and then notice matrix is above the x to the -1. So second function matrix. You're going to go over to edit, and you're going to edit number 1, which is the A matrix. So then you have to put in the size of your matrix. So if I look at my problem here, you can see that I have 2 rows that are male and female, and 3 columns, football, baseball, and hockey. So I'm going to do a 2 by 3 matrix. So I'm going to change those values that are up at the top and make that one a 2. The 3 is already in there. And then I'm going to change the data in the table. So I'm going to put my 18, 10, and 4. 18, 10, and 4. And then in the bottom, 20, 16, and 12. So once I have my data in my matrix, 18, 10, and 4, 20, 16, and 12, then I am going to go ahead and do my test. So I'm going to press Stat, cursor over to Tests, And this time I am going to do the C, which is your chi-squared test. So scroll down to C. C is your chi-squared test. You can also do the alpha button, which is the green one, and alpha in the program has C above it. So I could do it that way, but I just scrolled down to the chi-squared test. It's going to say observed is A, expected is B. The observed matrix was A. It's going to put the expected values in B, which we're going to do in a little bit. And so we're going to go down and calculate. So when we calculate our values there, you can see that my chi-squared value is 2.385. My p-value, 0.3034. All right, and then also the degree of freedom on there. The degree of freedom happens to be 2. You will need to know that sometimes when you do your hypothesis testing. The degree of freedom, they will tell you that you take the number of rows minus 1 and the number of columns minus 1 and multiply them together. So 2 rows minus 1 would be 1, 3 columns minus 1 would be 2, 1 times 2 is 2, and that's what we got there for our degree of freedom. So we will come back to answer that question on the, well, we could go ahead and answer the question. The p-value. The p-value is 0.303. If I'm testing it to an alpha value is 0.10, my p-value is greater than my alpha value. So my p-value is greater than my alpha value. That means I'm going to accept the null hypothesis. The null hypothesis on this one, it says, should you accept the null hypothesis that these items are independent? Since this is a test for independence, yes, they are independent of each other. We are going to accept the null hypothesis. Now, the next part of this is because when you are doing the work on Alex, they're going to have you fill out the table with the expected value and then what we did on the previous problems. So we have to do a little bit more work to get the table all the way filled out. So the next thing I'm going to do is the ones where you are going to find your expected values. So once you have your calculation done, it put the expected values in matrix B. So what we're going to do on our calculator to see those values is, my calculator gets into focus here, we are going to do second function in matrix again. So second function and the x to the negative 1 to get the matrix. We're going to go to edit, and this time we're going to edit, once I cursor over to edit, the number 2 one. The number 2 is your B matrix. That's where we had it put the expected frequencies. So I'm going to hit number 2, and you can see then that my expected values that you're going to list would be 15.2, 10.4, and 6.4 for the males for each of those. Then for the female football, 22.8, baseball is 15.6, and hockey is 9.6. So those would be your expected values. Now I'm going to slide down a little bit more on my paper here, so I'm going to go down on my computer. We are also going to do what we did on the previous problems and do the goodness of fit test. When we do the goodness of fit test, basically we're going to have to do each of these separately. I went down a little farther than I wanted to, see if I can still get my data. There we go. And so I'm going to have to do each of these separately, one for the males, one for the females. So I'm going to do exactly what I did on problems 4, 5, and 6, or which numbers they were, but the previous ones where we did the chi-squared goodness of fit thing. So I'm going to hit stat on my calculator and do my list. So stat, 1 for edit, and then I'm going to clear out my data here, and I am going to do the males first. And so for the males, we had 18, 10, and 4. Then we have to put in the expected values that we just calculated. So our expected values, we had 15.2, we have 10.4, and we have 6.4. 15.2, 10.4, and 6.4. I am then going to hit Stat, like I did before when we did the previous problems. Cursor over to Tests, and then I'm going to do D. So I'm going to do alpha and the x to the negative 1 to get to D, and do the goodness of fit test. So I've got my observed in list 1s, the expected ones that I calculated in list 2, my degree of freedom. I have 3 items, so 3 minus 1 is 2, so my degree of freedom is 2. And then I'm going to calculate. So then remember the CNTRB values. Those were the values when we calculated the observed minus the expected squared divided by the expected. And so in that column, we are going to have for the males 0.516, and then we'll have 0.015, and then we have 0.900. Then you're going to repeat the process to do the females. So again, I'm going to hit Stat, and I'm going to hit 1 to edit and change my lists. Since I have the same number, I'm not going to worry about clearing them. 20, 16, and 12 for the females. And then my expected frequencies from my previous calculation, 22.8, 15.6, and 9.6. Once I have those values in my list, I can go ahead and do my chi-squared goodness of fit test. So I'm going to do Stat, cursor over to Tests, and then go down to D. Again, you could hit alpha D, but you're doing the goodness of fit test. And so I'm going to enter on there. Okay, my list 1, my list 2, degree of freedom again is still 2, and I'm going to calculate. And then I'm going to use that CNTRB. And so for the females, the first one 0.344. Then I have 0.10. And then if I cursor over to the last one, I have 0.600. So once we get to one from Alex, you'll see why I did those extra calculations. But we're going to go ahead and go on to the next question here. So the table below shows the number of years of college a person has completed and the residence of the person. We're using an alpha level of 0.05 to determine whether the number of years of college a person has completed is related to the residence. So again, we're going to put that into a matrix. And so I am going to hit second function and the x to the negative 1 key to do the matrix. I'm going to go over to edit. And I'm going to edit number 1, and this time I have a 3 by 3 matrix, 3 rows and 3 columns. So I'm going to enter that in, and then I'm going to change the matrix to the numbers that I want there. And so 15, 12, and 8. And then the next one is 8, 15, and 9. And then the bottom one is 6, 8, and 7. So once I have the values in my matrix, I am going to do my hypothesis test. And so I am going to hit Stat, go over to Tests, and do C. So I can do alpha and hit the program button, and it will pop me down to that chi-squared test. Observed A, we're going to put the expected in B. We're going to go ahead and calculate. So on this one, your test statistic, chi-squared, 3.01, p-value 0.557, 0.557. Degree of freedom in this problem is going to be 4. I would do n-1 and n-1. 3 minus 1 is 2, 3 minus 1 is 2, and 2 times 2 is 4. So that's how they came up with a 4 there. So if I look at my p-value compared to my level of significance, my p-value 0.55 is greater than 0.10, So in that case, I am going to accept the null. If I'm accepting the null, then these items are independent of each other. So I'm going to accept the null on this one. Now again, once you're on Alex, you're going to have some tables to fill out. So to do your tables, you are going to do your matrix first of all. So I am going to go to second function again and down to matrix. And I'm going to edit number 2. Number 2 is going to still be a 3 by 3 matrix, but then it's going to give me my expected value for each of those. So 11.534, 13.92, 9.5455, and so forth. I'm going to pause the video, write those numbers down because I'm going to need those in order to do the next part. Alrighty. Now what we're going to do is the goodness of fit test for each of those. The urban separately, the suburban, and the rural. So I am going to go to my calculator. I am going to hit stat. I am going to do number 1 to edit. And I am going to go ahead and do the urban, 15, 12, and 8. And then on my list 2, I'm going to do the observed values that I just wrote down. So 11.534, 13.92, and 9.5455. Once I have those values in my list, then I can do my goodness of fit test. So I am going to hit stat, go to tests, and do D. So I'm going to do alpha and x to the negative 1 to get down to my goodness of fit test. Observed in list 1, expected are now in list 2. My degree of freedom is going to be 2 because we had 3. 3 minus 1 is 2, so that is good. And then I'm going to calculate. And the CNTRB values are the values that are going to go in there for that calculation. So I'm going to go ahead and write them down. I have 1.042, 1.042. I have in the middle value 0.265, 0.265, and the end value 0.250. Now we have to repeat the process for the suburban. So again, I'm going to hit stat. I am going to do number 1 to edit. And then I'm going to edit my information for the suburban 8, 15, and 9. And then my expected values that I calculated that I wrote on my paper. So 10.545, 12.727, and 8.7273. Once I have those values in my list, I can go ahead and do my goodness of fit test. So I'm going to hit stat, cursor over to tests, whoops, try that again, stat, cursor over to tests, and do alpha matrix D, alpha D, and observed in list 1, expected in list 2, 2 degree of freedom, and calculate. So again, I'm going to go ahead and write those down. So for the suburban, I've got 0.164. So the first one was 0.16, or no, 0. I wrote down the wrong thing. Hopefully you're doing better than I am. 0.614. The second one, 0.406, 0.406, and then the third one, 0.009 when I round that off, 0.009. Now we have to repeat that process a third time. So again, I'm going to hit stat. I am going to do number 1 to edit my lists. And I'm going to change my lists to 6, 8, and 7. And then I am going to do my expected frequencies that I wrote down. 6.9205, 8.3523, and 5.7273. Once I have those entered into my list, I can do my goodness of fit test. So I'm going to go ahead and hit Stat, cursor over to Tests, and do D again. So alpha, D, and again, I have list 1, list 2, my degree of freedom still 2, and I'm going to calculate and write down those values in the CNTRB. So I have 0.122, the second one, 0.015, 0.015, and the third one, 0.283, 0.283. All right, so the last one here is the one from Alex, and you can see how it looks and why I did those extra calculations on those two previous examples. So the question says that fast food restaurants are always looking for ways to cut down on expenses. Believe it or not, such restaurants may be able to decrease their yearly expenses simply by decreasing the size of the paper napkins they provide patrons. So, Papal Paper Products, a major paper company, is hoping to infiltrate the restaurant supply market and is pitching the smaller napkin idea to potential restaurant clients. To determine the receptiveness of different restaurants to the ideal, Papal surveyed 400 fast food establishments chosen at random, classifying attitudes as not receptive or receptive. Papal's data are summarized in Table 1, and then we got to fill in the contingency tables, do all our calculations, and perform our hypothesis testing. And so I am going to go ahead and slide down here to what the table looks like. So there is the table that we have in order to do our contingency testing. All right, so we have our table that we have to fill in. And so first thing we're going to do is our matrix. We have 2 rows, receptive and not receptive, 3 columns, burgers and sandwiches, Chinese and Mexican, or other. So again, on our graphing calculator, we are going to do second function. Where's my graphing calculator? There we go. Wait for it to get somewhat clear. Second function, and then we're going to do the x to the negative 1 that says matrix, second function matrix. We're going to cursor over to the word edit, and we're going to edit number 1, which is our A matrix, which we want as a 2 by 3 matrix because we have 2 rows and 3 columns. We're then going to enter our values in. So you can see there I use 66, 134, and 40 for my first row. The second row is my not receptive, 34, 76, and 50. Once I have the data in my matrix, I'm going to do my test. So I'm going to do stat, cursor over to tests, and then I'm going to do C, which is my chi-squared test, and I'm going to enter on that. So the observed value is in matrix A. They're going to put the expected value in B. We're going to go ahead and calculate. So when we calculate that, we get our information, but we're going to jump down to table 2 and actually do that first before we do table 1. So table 2 wants to know the type of test statistic, which is your chi-squared. The degree of freedoms, if you look here on your calculator, it had 2 for your degree of freedom. The value of my test statistic is 11.84. They're going to round that to 2 decimal places, 11.84. My p-value, 0.003, rounding that to 3 decimal places, 0.003. So it says, can we conclude that the variable type of fast food restaurant and attitude toward the smaller napkin idea are associated? Use a 0.5 level of significance. So if we look at our p-value is 0.003. 0.003 is less than 0.05, which means we would have to accept the alternative hypothesis and not the null hypothesis. So the question says, are they associated? So your null hypothesis would be that no, they are not associated, and my alternative hypothesis would be yes, they are related. And so the question wants to know, can we conclude that they are associated? And so, yes, we are going to conclude that because we are going to take our alternative hypothesis. Since our p-value is less than our alpha value, the 0.003 is less than 0.05, we are going to accept the alternative hypothesis, which says that they are associated. Now, the other part of this is we've got to fill in the top part of that table, which we didn't do yet. I've got to find my expected values. My expected values we had to do from our matrix. And so I am going to do second function, go down to matrix, and I am going to go to edit. And I'm going to edit number 2. Number 2B was where we put our expected values, which we haven't put in there yet. So now I know my expected values. So for the receptive, we have values of 60. You can see the 126 is already in there and the 54. So you'll want to enter the 60 and the 54. And then for the not receptive, we have values of 40, 84, and 36. So we're going to put in the 40. You can see the 84 is already in your table and the 36. So once you have those expected frequencies written down, now you can go ahead and go to your list and fill out the value for your goodness of fit. The observed minus the expected squared divided by the expected. So I am going to go to stat again, number 1 to get to my list. I already put in the first list for the receptive, and so now I got to put in my expected values that we just brought up from that table. And so my expected values again for the receptive were 60, 126, and 54. So once I have those values in my table, then I can go ahead and do my goodness of fit test. So I am going to hit stat, cursor over to tests, and I am going to do D. So I am going to do alpha matrix to jump down to my goodness of fit test. I have my observed in list 1. I have my expected in list 2. My degree of freedom, we had 3 numbers, so 3 minus 1 is 2. We can leave that at 2 and go down to calculate. And the CNTRB, we're going to have those values. And so for the receptive, the first value we got was 0.6. 0.6. The next one you can see they have entered in 0.508 when they rounded that off to 3 places. And then the third one, we're going to use 3.630 because I have to round my 29 up to 30. So 3.630. Then we're going to repeat that for the not receptive. So I'm going to go stat. I'm going to hit number 1 to get my list. And I am going to put in 34, 76, and 50. 34, 76, and 50. And then I'm going to do the expected values that I found. And so my expected values were 40, 84, and 36. Once I have those values in my calculator, I can go ahead and do my goodness of fit test. So I'm going to hit stat, cursor to tests, and go to D. This time I'll scroll down to D. My goodness of fit test, when I enter, those should be all the same. List 1, list 2, 2 degree of freedom, so I can calculate. And so my CNTRB values, the first one 0.9, 0.9. The second one you can see they have in there already 0.762, rounding to 3 decimal places. And then the last one we're going to do 5.444. 5.444. So that is how you would use your graphing calculator in order to do the ALEKS problems. I've also uploaded a couple more examples, which will be under the instructor resources.